Yeah, I can bring the picture up, but it's not set up. Like, it won't hook up to the computer. Okay, so slope fields. Next thing we do, at this point, we draw the line segments at the points with the respective slopes. Okay, so what this is going to look like, I'm going to have to juggle. No, because it's got to be relatively close to you in order to pick up the sound. We're going to have an x and y axis, obviously, so draw your x and y axis. Oops. Okay. Yeah, come on, pretty big. Okay. And this is going to be your solutions for a family type of solutions for y prime equals 2x plus y. Okay, so that's what we're going to be looking at. Okay, so what we want to do is we want to take our points now. Let's say I have -2, -1, right? That was one of my points. So if I go over -2, -1, I'm going to draw a slope, a little line segment at that point of -5. So what did we say -5 was? It's pretty steep, right? Okay, so it looks a lot like this. I should do this. Okay. So we're going to have a line segment there. So we're going to just a little bitty line segment that shows the slope. Okay. Now we have the point -2, +1, and we had a slope of about -3. Is it going to be a slope as steep? No, it's not going to be as steep. So we go -2, +1. It's going to be right up here, and it's going to look maybe like that. Not as steep as the -5, but still in that negative direction. Okay? Keep going. I've got -1, -1 now, right? -1, -1 was a -3, so it's going to look just like this, except it's going to be in this spot. It shouldn't be parallel. It should be a little less steep than my 5. I apologize. Okay? Next one, -1, +1, and we had a slope of -1. Just going to look like this. Zero, -1. We had -1. 0, +1. We had a slope of 1. What happens at 0, +1 with the slope of 1? It's going to change that direction, isn't it? So now it's going to look like this. Notice it's changing on us. One, -1, we have a slope of 1 as well. So we go over 1, -1, we have a slope of 1. You see what's kind of happening? Starting to notice a pattern? Where am I? 1, 1, we have 3. So here's 1, 1. We have a slope of about 3. It starts to get steeper. Two, -1, we have another slope of 3. So if this is 1, 1, this is 2. What did I say? 2, -1. I go down here, and it's going to be a slope of 3, so it's getting a little bit steeper. And we have 2, 1, which is a slope of 5. God bless. So it's a little bit steeper. Do you notice how it's starting to kind of move that direction? Change directions? A little bit? Okay, we need to do more points, don't we? Why don't we use we'll use the grid board up here, and we'll finish this problem on the grid board. And I'll have each of you pick 10 points, do 10 points, and we'll complete it up on the board. Okay? All right. So back on track. Stephen Buell, what are you working on?
I'm trying to organize my notes.
Oh, jeez.
For this class.
Okay, separation of variables. This is another way to solve differential equations. This is the most commonly used form. This is also the one that is tested the most on the AP exam. Okay? I actually enjoy doing this. It does require some algebra. He's not here today. He'll be back Thursday. Okay? So, consider the differential. What? Shh. Shh. Consider the differential equation that can be used in the form. You ready? This is just a form. Don't get too worried. Mx plus ny dy dx equals 0. Okay, you'll understand this more when we use it. Okay? Where m is a continuous function of x alone and n is a continuous function of y alone. So that means they only contain x's and they only contain y's. M and n. Okay? And we call these separable. When you think of the word separable, what do you think of? Separate, which is exactly what we're going to be doing. Very good, Andrea. What? What did you say? What do you think of when you hear separable?
I didn't say anything.
He's a weaselly one. Okay. Original differential equations. All right, we're going to have 2 columns, and we are going to separate the variables, okay? Let's say I have x squared plus 3y dy dx equals 0. And I want to separate it. I want to get all the y's on one side and all the x's on the other, okay? What's the first thing you think I should do? How about you, Adam? What's the first thing you think I should do? Sure. Okay, let's say I have negative x squared on one side. We're going to set that equal to 3y dy dx on this side. I have a problem, don't I? Yeah, I still got dy dx. I want to get that dx over to my negative x squared side. Good. Multiply it. When I multiply both sides by dx, I get negative x squared dx equals 3y dy. My variables are now separated. Once we get to this form, then we're able to solve the differential equation, and you'll see when we get a little bit further down how we do that, okay? Right now I just want to work on separating these variables. All right, how about if I have y prime sine x? That's odd. Y prime sine x equals cosine x. And I want to separate these. Now, this one's a little trickier. How can I rewrite y prime? Good. Rewrite it as dy dx, okay? That's going to help you. So, dy dx sine x equals cosine x. Now this one's going to require a little trick. Think about sine and cosine, okay? They've both got an x attached, right? So we know we want them on the same side. How am I going to get one of those over to the other side? Divide by it. Very good. Very nice. Okay, if I divide sine x over, I get cosine x over sine x, which is, like Andrea said, cotangent x, okay? So now I'm stuck with dy dx equals cotangent x. Am I done? No. What else do I have to do? Multiply by dx. Good. So I get dy equals cotangent x dx. Very nice. Okay, I'm going to erase this part. So we just have to finish the solution. Okay? Are we all right so far? Are we grasping it? Adam, you all right? Steven? For now, Jesse? Charlie? How about you girls? You're awfully quiet up there.